Here we have the instrument connected to a single probe. That probe is connected to the probe compensation output on the front of the oscilloscope. The purpose of this output is to adjust the probe for best frequency response and also to validate the operation of the oscilloscope, and that's what I'm using it for today. The probe compensation output outputs a square wave signal at 5 volts peak to peak. As we can see, we have a square wave on the screen which is currently being connected to channel 1. If we look at this in more detail, we can move the waveform up and down using the position knob. We can see that the instrument is set to 5 volts, which means 5 volts per division. As you can see, this seems to be about 1 division. It's not the most accurate way of measuring the signal, but it validates that it's working properly. If we look at the menu for that input, press the menu key, we can see the coupling is DC. Change the coupling to AC. Position shifts a bit, which is normal because it's not then centered around 0 volts. We need to readjust the triggering to get that to lock, so we can adjust that and it locks OK. We can also set the input to ground, which disconnects it from the outside world and internally grounds it. So by doing that we get no signal. So normally you'd have that switched on AC or DC depending on the type of signal. So channel 1 appears to be working normally. If we connect the probe to channel 2, just move channel 1 out of the way and look at channel 2, so you can move the waveform up and down. It's not triggered because the oscilloscope was previously triggered to channel 1, so if we go to the trigger menu, channel 2, it locks. And again we can see the signal is about 1 division, so that's about a 5 volt signal. If we look at the menu for channel 2, we can change the coupling, AC, ground and DC. And again you can see it moves quite happily up and down on the screen. If then we move the probe to channel 3, again we have a waveform appearing. If we set the triggering to channel 3, it locks. If we move the position, if I set that to channel 3 and move the position, I can see it moves. If we look at the amplitude of the waveform, the input is set to 5 volts, and I can change the size there and adjust the time base. And if we look at the menu, we can change the coupling again. So currently it's on DC, to AC, it moves, which means it's not centered around 0 volts, and ground means it's internally grounded. So channel 3 seems to be functioning fairly normally. Lastly, if we move the probe to channel 4, first thing we notice, I'll just clear the menu, first thing we notice there actually isn't a waveform for channel 4. If I select channel 4, two things happen. Firstly, channel 3 turns green. I don't understand why this is happening, but it does. Secondly, if I move the position of channel 4, nothing happens. There's still no waveform. Nothing appears at all on channel 4. If I press the, if I press the channel 3 button again, channel 3 turns the right colour. Weird, but seems to be part of the fault. But looking at channel 4, nothing's there. Now, that's not always the case. Depending upon the time-based setting, something may or may not appear on channel 4. So if I change the time base slower, channel 4 is dead. If I change the time base faster, something appears. Now this is not the signal I'm inputting into the oscilloscope. The square wave signal that's coming from here, this clearly is not a square wave signal. If we look at the triggering, go to the trigger menu, set channel 4, Doesn't seem to lock onto a square wave. If we increase the time-based settings, see exactly what this is. Just seems to be sort of random junk. Now, interesting, if we look at channel 4, it's not possible to actually move this about. On the other inputs it was possible to change the position. If we select channel 4, press the position, choose the position knob, you can see the pointer here moves up and down as we move the position, but the thing on the screen is not changing. Also, if we look at this signal, it is actually very big. This input is set to 50 volts per division, which means each square is 50 volts, which would mean that this would be more than, say, 200 volts or so of signal, which is completely crazy, since we actually, even if I disconnect it, it's still there, 5 volt signal going in. If we look at the menu for channel 4, so this is channel 4 coupling. Again, if we go AC, doesn't really change it much. DC, or sorry, ground. If it's grounded, that should be showing nothing, but it's showing a big signal, which is 50 volts per centimeter. If we change the amplitude of this input, so 20 volts, 10 volts, 5 volts, 50 volts, 100 volts. So apparently, if this scope is working correctly, there is a signal of, say, 1, 2, 3, 4, 500 volts. So there's a 500 volt signal here. It should be electrocuting me now when I touch this, but clearly isn't. So this is made up. If I unplug the input, the 500 volt signal still there. It changes the setting on the screen because these probes have detection for their type of probe. So it's gone to 10 volts, but still the signal hasn't changed. It's still there, and this scope is defective. I believe this problem would be very clearly noticeable and should have been noticed if someone had actually checked the oscilloscope before shipping it. This would have been a very noticeable, clearly obvious problem which anyone familiar with this type of instrument would have actually seen.